So our critical value, or we can call it T star, is 2.064. It really doesn't matter. This is just notation. I think in the last videos when I was doing the Z testing, I kept writing CV for critical values. You could also use Z star. That it's up to you. So this is going to be our critical value. Let me draw a picture now of what's going on. So since this is a two-tailed test, we have technically two critical values. The positive critical value is positive 2.064. The one on the left side is going to be negative 2.064. And remember, once we calculate our T statistic, and we already did calculate it, if it lands in this red area, these are our rejection regions. This is when we reject the null hypothesis. If it lands in the middle here, we fail to reject. So just the same exact idea from hypothesis testing last week with the Z. So let's go ahead and write out the decision rule, because Hawks will have you do that sometimes. So the decision rule, we are going to reject H naught if, now this is a two-tailed test, so there's two possible situations. We reject if T is less than negative 2.064, or T is greater than or equal to, less than or equal to, greater than or equal to positive 2.064, right? If it's less than this value, negative 2.064, or if it's greater than. So this is our decision rule. Step 5 then is actually to compare. Look at our test statistic, look at our critical values, see what's going on, and we'll be able to make our decision. So step 5, our T was 0.25, right? So is 0.25 less than or equal to negative 2.064? I guess I don't need to put two question marks. There we go. Or is 0.25 greater than or equal to positive 2.064? Well, definitely not, right? 0.25, that's going to be very close to our mean here in the middle. So let's say it's like right about there. That's definitely falling in our fail to reject region. So yeah, we fail to reject the null hypothesis. Now the last step, as always, is to reword the problem in terms, or reword the conclusion in terms of the problem. So we could say that there is not sufficient evidence to show that the new technique performs differently. Okay. And there we go. That is the conclusion of our hypothesis test. And that was a two-tailed hypothesis test using the T statistic. All right, let's do it again. So second problem here. A manufacturer of chocolate chips would like to know whether its bag filling machine works correctly at the 434 gram setting. Let me highlight here. It is believed that the machine is underfilling the bags. Okay. We're going to be coming back to underfilling. A 26 bag sample, so it's less than 30, we're definitely going to be using a t-statistic, has a mean of 426 grams with a variance of 289. So again, they're giving us the sample variance. A level of significance of 0.05 will be used. Assume the population distribution is approximately normal. Is there sufficient evidence to support the claim that the bags are underfilled? All right, let's get to it. So, first step, our null hypothesis. So, hopefully you can, download my notes and be looking at that while this video is going on. I don't want to keep having to scroll up to the problem. But I will scroll up for this one part. Remember this first sentence. A manufacturer of chocolate chips would like to know whether its bag filling machine works correctly at the 434 gram setting. That means that's what they built it to do. That's what it's designed to do. So that's going to be the value we use in our hypotheses. So our null hypothesis is mu is equal to 434. Our alternative hypothesis, so they want to know if the bags are being underfilled. So that would be less than, right? Less than 434. All right, level of significance. They stated in the problem they want a 0.05 level of significance. And then let's go ahead and calculate our test statistic. So before I just plug everything into the formula, let me write out what these actual values were. So the sample size was 26, right? Which, again, that's the big sign that we need to use the t-test statistic. The sample mean was 426. And again, they gave us variance, not standard deviation. So for variance, we use s squared. And the variance was 289. But we want the sample standard deviation. So we're going to square root both sides there. So our sample standard deviation is actually going to be 17. So now we can plug these values in. T is equal to 426 minus the mean that comes from the hypothesis test, 434. I'm sorry, the null hypothesis. This is the hypothesis test, what we're doing. But yeah, the second value comes from the null hypothesis. That is all divided by the sample standard deviation over the square root of the sample size. So once again, you can pop that into Desmos. I'm going to give you an approximation. And I'm going to round it to 3 decimal places. So I'll show you both steps. Originally, I get negative 2.3995 ... keeps going. Well, I'm actually going to round that to 3 decimal places. But since this is a 0.399, we're going to round that up to 0.400, right? 399, round that up to 400, essentially. So this is going to be our test statistic. Step 4 is let's figure out our critical values and our decision rule. So step 4 here, critical values. So remember, you need to know your degrees of freedom, which is the sample size minus 1. So our degrees of freedom is 25. And is this a one-tailed or a two-tailed test? Well, this is a less than symbol. This means this is going to be a one-tailed test. And the area in that one tail is going to be the significance level 0.05. All right, so we're going to pop over to our t-table. In Hawks, you would select the one-tailed area t-table. Erase the information from the last problem. Okay, so now for what I have, I'm going to look at this one tail row, and I'm going to look for 0.05, which is right here. And then we go down to the degrees of freedom, which was 25. So that's all the way down here. 1.708. Ooh, I should take off the highlighter. There we go. 1.708. Now, let me actually draw a picture, though. There's a little bit more to this one. So we're testing to see if the mean is less than 434. So our critical value is going to be on this left side. So if it's on the left, that means it's actually going to be a negative value. So it's going to be negative 1.708. So I'm going to throw that negative out in front over here. And that's always going to happen when we are dealing with the less than. So our rejection region is going to be everything to the left of that. So what is our decision rule? We are going to reject H naught if our t, test statistic, is less than or equal to our critical value, negative 1.708. So now we actually got to test that out. Step 5 is, I guess that should be a capital I, right? Is negative 2.400. That was our t test statistic, which we found back in step 3. Is that less than or equal to negative 1.708? Absolutely, yes. So that means it's living to the left of negative 1.708, and it's living in the rejection region. So we are going to reject the null hypothesis. So our final conclusion, to put this all into words, there is sufficient evidence to show that the bags are being underfilled. Whoa, okay. Yeah, my OneNote has been funky ever since I updated my operating system. Go figure, technology, right? Okay. All right, that is our second hypothesis test. Yay.